All right, good morning, everyone. Good morning. Hope everyone's doing all right. Everybody's doing well. So today we're looking at 7.3, probability and odds. Get this light real quick. All right, so probability and odds. So we'll start off with a few terms that we've already discussed in the previous section. Because of how the homework set it up, they had these terms in there, so I want to make sure you got them early. So some of these terms, like I said, will be terms that we've already discussed, but they were discussing them again in this section because that sets us up for probability. So probability is the likelihood of the occurrence of a particular event. Probability will always be in between 0 and 1, inclusive. So that means it is possible for it to be 0, so 0% chance of something happening. It means it won't happen. Or 1, which is representative of 100%. All right, so an experiment is any occurrence for which the outcome is uncertain. Example of that is flipping a coin. Going up on a dark blue. All right. And then our sample space is a set of all possible outcomes of an experiment. Usually we use capital S to notate this is our sample space. For flipping a coin, sample space would be heads and tails. Let's go down experiment. All right, so then event is just any collection of outcomes from the sample space. You use any capital letter for that. Normally try to refrain from using S because, held that back for sample space. Anybody want on the sample space? All right, example of an event, just the probability of landing tails face up, your event would be tails. All right, so the way we compute probability is notice the notation P parentheses E represents the probability of your event. If your event is called E. You take the number of outcomes in your event, place it over the number of outcomes in your sample space. So that's what N parentheses E stands for, the number of outcomes in your event. N parentheses S, the number of outcomes in your sample space. Going up some. So going back to our light example, flipping the coin. Hey, I'm doing. So you flip a coin, you want to know the probability of landing tails face up. First thing you want to do is examine the sample space. Sample space, we already said was heads and tails. So there's two outcomes in your sample space. There's only one tails. So for our event, there's only one outcome. Once you have those two numbers, you place your event number over your sample space number. That's 1/2. That's your probability. Scrolling up. So let's look at first example. So a die is rolled once. Find the probability of rolling a 3. All right, so giving a couple steps on how we're going to do this. First thing we want to do is establish the sample space. It's always the easiest way to attack probability problems. So notice we're dealing with a single die. We never dealt with a die or dice before, board games and Monopoly, whatever the case may be. They have 6 faces. Normal die has 6 faces. And they are created by what we call pips. These over here, these little dots on each side are pips, and each side represent a number. So the 1 pip represents number 1, 2 pips, number 2, and so on. So our sample space is 1 through 6. So that means the number of outcomes that we have in our sample space is 6. So also I want to point out, don't get these 6s confused, that these 2 6s are not the same number. So in other words, this could have been 1, 2, 3, 4, 5 triangle, and the number of outcomes that we have is still 6. So I didn't want us to think that because that ends in 6, our sample space ends in 6, that the number of our sample space is 6. Those are 2 different numbers. That could be, 1, 2, 3, 4, plus sign, circle. What I mean? As long as there's 6 outcomes, the number of outcomes we have will be 6. So put that 6 back. Okay. So you establish your sample space first. Whenever dealing with probability, you want to establish your sample space first. Then we look at our event. Our event is rolling a 3. When we look at our sample space, you notice there's only 1 3. So my event number is 1. And now we can calculate the probability, placing the 1 over 6. So we have 1 out of 6 chance. So rolling a 3. All right. Rolling up on some. Anybody hold on to the red up top? All right, next one. Same problem, but this time we want to know what's the probability of rolling an even number. Sample space is still 6. But this time when we look at our sample space, you say how many even numbers are there? There are 3 because it's 2, 4, and 6. So now that we have both of those numbers, you place the 3 over 6, and that reduces down to 1/2. All right, and one more dealing with is single die. All right, we want to know what's the probability of rolling a number greater than 10. So once again, our sample space is 6, but there's no number that's greater than 6 in our sample space. So of course, there's no number greater than 10. So if you see a circle with a slash, I didn't see what Webassine actually showed you the symbol or not, but it's possible. That just represents the null set, which means that there are no elements in your sample space that meet those characteristics, or this characteristic in this case being greater than 10. So the number of elements in our event would be 0. So the number of outcomes in our event would be 0. And if you want to finish off doing the math, 0/6, it would just be 0. So there's a 0% chance that you can roll a number greater than 10. Everybody good? Scrolling up. Oh, not scrolling up. I need to go to 2 dice. Everybody good? All right. So they also gave an example of rolling 2 dice instead of just 1. So let's say we had 2 6-sided dice and we throw them down. How many outcomes are there if you roll 2 fair dice? So in other words, what's my sample space? What's the number of my sample space? So when you're talking about exploring how many total, with the total number of outcomes when you throw down 2 6-sided dice, you're talking about all possible scenarios. So when I look at die 1 being 1, die 2 being 1, die 1 being 1, die 2 being 2, 1 3, 1 4, 1 5, 1 6, and then explore all of the outcomes when die 1 is 2 and die 1 is, whatever. So you don't want to have to list all of those out. But what we can do is use the fundamental counting principle that we talked about in the previous section. We know that there's 6 sides to die 1, there's 6 sides to die 2. We only can choose one at a time. Whenever that's the scenario, that means we use the fundamental counting principle. Just multiply those together, and that'll let us know how many total number of outcomes we have or will have. And so 6 times 6 is 36. And that's going to be the number of our sample space. Let's say if I had 2 12-sided dice, then I would do 12 times 12, and that would be 144 total number of outcomes. All right, scrolling up. So looking at B, what's the probability of rolling a 7? Everybody holding on to that last page. Okay. So first of all, we know our sample space is 36. Well, the number of our sample space is 36. Now we need to explore what does it mean to roll a 7, or look at how many outcomes total do we have when it comes to rolling a 7. So we're talking about when I roll these dice, they add up to give us 7. And don't forget the extent of numbers that we have goes from 1 to 6. So here, if I roll a 1 for die 1, and for die 2, roll a 6, 1 plus 6 gives me 7. Then 2 and 5 is 7, 3 and 4 is 7. Now, die 1 being 3 and die 2 being 4 is different than die 1 being 4 and die 2 being 3. So then we do invert, all of these 3 possible scenarios. So then we got 4, 3, 5, 2, and 6, 1. So we have 6 outcomes that will add up to give us 7. Well, once you have both of those numbers, go ahead and place your event number over your sample space number. That's 6/36. And that reduces down to 1/6. Anybody holding on to D? Got one more like this? All right, what's the probability of rolling two ones? In other words, snake eyes. So same thought process, our sample space is 36. Now, when it comes to snake eyes, there's only one way to get that. That's when die one is one, die two is one. And that only happens one way. And so the event number is one, so the probability is 1/36. All right, we good on that one? All right, so we confirm, yes, nothing else down there. So let's talk about cards now. Just in case someone isn't familiar with cards. Standard 52 card deck, that means there are no jokers. We have four suits: spades, clubs, hearts, diamonds. Suits, just another word saying categories of cards. Two of them are black, two of them are red. The black suits, spades and clubs, red suits, hearts and diamonds. For each suit, there are 13 cards. 13 times 4 gives you 52. So each suit has 13 cards. 3 of them are face cards, 10 are non-face cards. The face cards are your king, queen, and jack. The non-face cards are ace, and the numbers 2 through 10. All right, scrolling up. All right, so you are dealt one card from a standard 52 card deck. Find the probability of being dealt a king. Anybody holding on to black? Black. All right, cool. So once again, you dealt one card from the standard 52 card deck. Find the probability of being dealt a king. So we know our sample space is 52. We don't need to list out every single card. We just need to know the number of cards or the number of options when it comes to our cards. So we have 52 cards. Our event is 4 because we have 4 kings in the deck. There's 1 king for each suit. So once you have both of those numbers, 4 over 52, we'll reduce down to 1 over 13. Got a 1 out of 13 chance of getting a king. Next one was the probability of getting a heart or being dealt a heart. Once again, our sample space is 52. Our event is 13 because there's 13 hearts. 13 over 52, 1 4. And one more dealing with this example. What's the probability of being dealt the king of hearts? So sample space 52, 52 cards. Now there's only 1 king of hearts. Remember, for each suit, there's 1. So there's a king of clubs, king of spades, king of diamonds, and 1 king of hearts. So this is what we want to know about that. The probability of getting a king of hearts. So just 1 over 52. All right. Scrolling up. Next thing we're looking at is probability of odds by holding on to the King of Hearts. So odds in favor of an event. You can take the probability of your event, place it over the probability of your event not occurring. Or if you're talking about odds against, take probability of your event not occurring, place it over the probability of your event occurring. So the probability of your event not occurring is called the complement. This book kind of does or introduce concepts a little bit backwards to me. Complement is what we're going to talk about in the next section. But I'll give you enough so you'll be able to navigate through odds. But normally you do complement first and then talk about odds because you can use complement to calculate odds, but you know, it is what it is. All right, for example, you roll a single die, find the odds in favor of rolling a two, find the odds against rolling a two. And notice when you look at your odds in favor versus your odds against, it's just the same fraction inverted or flipped. So keep that in mind as well. Right, holding on to the black. I don't know what the odds against. Scrolling up. All right. So once again, you roll a single die. You want to know what's the odds in favor of rolling a two, odds against rolling a two. So when rolling a two, our sample space is 6. We talked about a die before. Sample space is going to be 6, unless they tell you different. If they tell you it's a 12-sided die, then your sample space number will be 12. But normally your die is 6. An event number is rolling a 1. I mean, it's rolling a 2, so there's only one outcome in your sample space. That's a 2. So the probability of rolling a 2 is 1 out of 6. Over here on the right side, the probability of your event not occurring is subtracting your probability from 1. And so that's the complement. Like I said, we'll talk about that more in the next section. So 1 minus 1 over 6. That 1 turns into that denominator over itself. So that's 6 over 6. So that would be 5 over 6. That's our probability. All right, now scroll up on green. So now that we have both pieces, we can go ahead and calculate odds in favor. Like I mentioned before, to calculate odds in favor, that's the probability of your event over the probability of your event not occurring. So it's 1 over 6 divided by 5 over 6. This fraction bar and this division sign is the same thing. So I just took it from being vertical to right and horizontal. The problem, I should say, calculation. Whenever divided by a fraction, you multiply by the reciprocal. So that's why I have 1/6 divided by 5/6. That turns to 1/6 times 6/5. Those sixes cancel, and then when you multiply across, you're left with 1/5. Going up a little. Are they okay with the top? All right. So concluding statement for part A is the odds in favor of rolling a 2 are 1 to 5. All right, scrolling up. Are they okay with the red? All right. So the next one was odds against. Remember, I mentioned that if you already calculated odds in favor, then odds against is just flipping that fraction or inverting that fraction. What if you're doing the work that's 5/6 divided by 1/6? Those sixes cancel. Remember the work that we did in the last problem in part A. Those sixes will cancel, leaving you with just 5/1. So the odds against rolling a 2 are 5 to 1. Scroll up. Very good. All right, so let's look at the next one. The winner of a raffle will receive a new SUV if 500 raffle tickets were sold and you purchased 10 tickets. What are the odds against your winning the car? All right. So set up your probability and then you can calculate your event not occurring. So we know there's 500 tickets, so that's our sample space. We purchased 10 of them, so that's our event. Us winning by one of those 10 tickets. So the probability of us winning is 10/500, which reduces down to 1/50. Probability of that not happening is 1 minus 1/50. That one turns into 50/50, and that's 49/50. All right, now scroll up on the black. Mhm. So take the probability of your event not occurring, place it over the probability of your event occurring. That's 49 over 50 over 1 over 50. We saw that those 50s will cancel, leaving us with 49 over 1. Scrolling up on that last part. The odds against winning the USB, the SUV are 49 to 1. All right, can I scroll up? I'll go up too far and let me know. Next concept, last basically new concept. I just got a couple problems to reinforce it. Odds to probability. So if the odds in favor of an event are A to B, then the probability of the event is given by A over A plus B. So the odds in favor of a particular horse winning a race are 2 to 1, 2 to 5. What is the probability that this horse will win the race? Black. All right, so they give us the odds in favor of winning. It's 2 to 5. That means A is 2, B is 5. So then we plug it into the formula to calculate the actual probability of winning. That would be 2 over 2 plus 5. And that'd be 2 over 7. So probably this horse winning will be 2 over 7. Almost finished. So now after this, there are a couple problems that I saw in the homework that were similar, and they use certain terms. So I want to make sure we're good when we see them. So we'll do a few problems that are similar to some homework problems, and then I'll let you guys go. Everybody hold on to the purple. So the probability of an event is given. Find the odds in favor of that event. All right, so they give us 0.7. First thing we'll do is convert it to a fraction so we can relate it to what we just finished talking about. So if I want to write 0.7 as a fraction, I can write it over 10, right? That's 7 over 10. Whatever, or however many number of decimal places I have to the right of my decimal lets me know how many zeros I need behind my 1. So this is 0.7. There's only one decimal place over here, so I need 1 0. So that's 7 over 10. And if I had 2 decimal places, then I would need 2 zeros. That would be that number over 100. If it was 3 decimal places, that number over 1,000 and so on. So however many decimal places you have right here to the right of that decimal, that should know how many zeros you need down here. All right. So that's 7 over 10 as a fraction. And always feel free to check it by throwing it in the calculator so you can get the concept. You'll see how 7 over 10 goes back to 0.7. And that will always be the case. So the top number is going to be my event number. This bottom number is the total number of outcomes that we have. So if I want to know what's not my event, I can subtract that top number from the bottom number. So 10 minus 7 is 3. In other words, how many outcomes are not, my event? My event is 7. The number of outcomes that's not my event is 3. So the odds in favor is going to be 7 to 3. All right. Let's do another one to make sure we're all right. 0.44. So like I mentioned, if you have 2 decimal places, then I need a 1 with 2 zeros. So that's 44 over 100. That will reduce by 4. The other one could not be reduced. 7 over 10 does not reduce any, but 44 over 100 can be reduced by 4 to give you 11 over 25. Then from there, you follow the same process. My event number is 11. 25 is the total number of outcomes. So I subtract 25 We'll subtract 11 from 25, that'll give me 14. So my odds in favor is gonna be 11 to 14. And we got at least one more. If a card is randomly pulled from a standard deck of playing cards, what are the odds in favor of pulling a queen? Anybody hold on to that last example? So we know there are 4 queens in the deck. To figure out how many cards are not queens, you do 52 minus the 4, which is 48. Very similar to what we did in the last problem, taking the total number minus the number of your event. And that's 48. So then odds in favor is that 4 over 48, which is 1 over 12, as you reduce by 4, which is 1 to 12. Questions? Any questions? I think, yep, that's the last one. Questions, concerns, comments? About 7-3 or anything before we close out today? That's true. Well, next class, we'll get into 7-4. And from there, I think there's only 3 more sections coming out of chapter 8. So you're talking about 4 sections left as far as new material is concerned. And we'll keep going from there. Oh yeah, don't forget, this Sunday is 10th week grading, so make sure you get those grades in or those assignments in for 10th week. And everything should be reflected in WebAssign when you look at your date. All right. Your due dates. So you guys are good, I'm good. Have a good day, have a great weekend, have a great homecoming, right? And I'll see y'all on next class. Mm-hmm. Mm-hmm. Anybody in Zoom holding on before I close out? Oh, 1 second, let me see something.